Welcome to today's lesson. Today we are looking at what is known as the Tan-Chord theorem. Let's read the statement. The angle between a tangent to a circle and a chord drawn from the point of contact is equal to the angle in the alternate segment. The angle between a tangent and a chord. So we have a circle. Let's say we have a circle with center O, and then we have a tangent. Let's say it's A, B, C. And now they're saying the angle which is between the tangent and a chord. So let's say our chord is called BD. Now, if you look at the tangent ABC and the chord BD, we have two angles in between. We can say we have B1 and we have B2 here. Right, but so that we don't complicate the theorem, let us talk about B1. So they're saying we need to prove that this angle which is between the tangent and a chord, B1, it's equal to the angle in the alternate segment. So meaning our chord, BD in this case, it's actually subtending two angles. One in the major segment and the other one in the minor segment. So B1 is in the minor segment, so it must be equal to the angle in the alternate segment, meaning in the other segment. So if it is in the minor, then it must be equal to the one in the major. So hence they say alternate. So if it is this one, which we said, we can say it's B2, then it must be equal to the angle in the other segment. So we need, it means chord BD must subtend an angle here. Right, so let's see. If we talk about B1, so the angle must be subtended in the other segment. Right, so we can call it an angle E. So we can say it's E, let's just say it's E1. So we are required to prove that B1, angle B1 equals to angle E1. This is what we are required to prove. So let us prove. So you know, when we prove a theorem, we must start with construction. Right, so we are going to construct. So let's do construction. Now in our construction, we are going to start by drawing a diameter. We draw a diameter. So let's call it BOF. So we draw a diameter BOF. We draw a diameter BOF. And join F either to D or to E. So we are going to explore both options. But let's start with the easier option first. So let's join F to E first. So we join F to E. So we draw a diameter BOF and join F to E. Right, now we have our E1 and we have our E2. Right, so we can start proving. Remember, we want to prove that B1 equals to E1. So we start with the theorem about diameter. We said that the angle subtended by a diameter is a right angle. In other words, we will say E1 plus E2 is 90 degrees. Angle subtended by a diameter, or you can simply say angle in a semi-circle. It's an angle in a semicircle. So it's an angle in a semicircle. So E1 plus E2, it's 90, is subtended by the diameter BOF. So again, if we look at angle B1, let's say this angle is B2. Let's also write that one. All right. So let's look at that. B1 plus B2. Angle B1 plus B2, it's also 90 degrees. Angle B1 plus angle B2, it's also 90 degrees. Tangent is perpendicular to a radius or diameter, whatever you want to use, whether you use radius OB or diameter BOF. So we said that tangent is perpendicular to the radius. So this is a tangent, this is a radius. So tangent is perpendicular to the radius. But if we look at this angle E2, if we look at angle E2, but angle E2, it's actually equals to angle B2. Angle E2 is equals to angle B2. If you look at B2 and E2, they are actually subtended by chord FD. So they are angles in the same segment. Angles in the same segment. So these are angles in the same segment. So now if we look at this, we are saying 90 equals to 90, E2 equals to B2. Therefore, we can simply say E1 equals to B1. Or if you want, you can say, suppose E2 was 30, then E1 will be 90 minus 30. But we say E2 equals to B2. If B2 is also 30, so B1 is also 90 minus 30. So can you see they will both, E1 and B1 will end up giving us 60. So we can therefore conclude that, therefore, from these two statements, and that the fact that E2 equals to B2, therefore E1 equals to B1. Angle E1 equals to angle B1. Right, that was our required to prove. Remember, we wanted to prove that B1 equals to E1, and we have proved it. So if you look at it, it's very easy actually. You just start by saying E1 plus E2 is 90 degrees. It's an angle subtended by a diameter, or it's an angle in a semicircle. And you also say B1 plus B2 is 90 degrees because it's a tangent is perpendicular to the radius. And then, but you realize that B2 here equals to E2 because they are subtended by the same arc FD, or they are the angles in the same segment. They are the angles in the same segment. Now, if that is the case, it means therefore that B1 equals to E1. Right. Now, I want us to look at a situation whereby we construct the other side. So, in other words, we have the same situation. We construct, so we set our tangent, it's ABC. We have our tangent ABC, and then we have the center, and then we know the center is O, so we said we construct. All right, so here it's E here, and we have a D there. Right, so this is F. So now remember, we have our B1 here and B2. So we want to prove that B1 equals to E1. And now we don't want to construct EF. We don't want to join F to E, but we want to join F to D. So now let's join F to D. Right. So if we join F to D, our first statement will be angle D, the whole of angle D equals to 90 degrees. Like in the first place, we had E1 and E2 being 90 degrees. Now we will say D is 90 degrees. Same reason, angle in the semicircle or angle subtended by a diameter. So D is 90 degrees. Now if D is 90 degrees, then you look at triangle FDB. So it means therefore that the F plus the B2, it's also 90, because already in this triangle the D took 90 degrees, therefore the F plus the B2 must also be 90 degrees, because the sum of angles in a triangle, so the sum of angles in a triangle is 180. So already the D took 90, so it means the F and B2 are remaining with the other 90. So the sum of angles in a triangle must give us 180 degrees. Right. So now again we come to that statement that B1 plus B2, it's also 90 degrees. It's a tangent is perpendicular to the radius, or diameter. Tangent is perpendicular to radius, or if you want you can say diameter. Right. So now we can make a simple conclusion here. This is 90, this is 90, this is B2, this is B2. Therefore we conclude that the F equals to the B1. From these two statements, we can conclude that B1 and F are equal. But we know that angle F equals to angle E1. They are angles subtended by the same arc, in this case, or chord BD, or they are angles in the same segment, or they are angles subtended by the same arc. Right. Now from here we can now conclude, if F equals to B1 and F equals to E1, it means therefore that B1 equals to E1, because they both equals to F. So this is another way if we construct it this side. So but at the end of the day we will still have our theorem proved. But the first one is shorter because it doesn't include the fact that the sum of angles in a triangle is 180. So this is the proof of the Tan-Chord theorem. So when we give a reason, we will say this is a Tan-Chord theorem. It's Tan-Chord theorem. Thank you very much. Please don't forget to like, subscribe, and share.